You are welcome to my YouTube channel. This is your teacher again. I've come back to continue with the series which we started about Senior 3 Mathematics. Today we are looking at the next topic 2 called Trigonometry 1. So we are continuing in the series to see that we reach the final topic, the 13th topic. Let's dive into this topic, but before you do that, I request that you first subscribe to this YouTube channel and also like this video. Please hit the subscribe button to keep me moving. Let's now move into this second topic and see what is trigonometry 1. Now, I've broken it down into several subtopics. The first subtopic is the introduction of trigonometry. Then we shall also look at the unit circle, because we can't talk about trigonometrical functions without the unit circle. Then we shall look at how we can deduce or derive some formulas for trigonometrical functions just from the unit circle and the equilateral triangle and also the right angled triangle. Then we're also going to look at finding sine, cosine and tangent and their inverses using a calculator. How do you find sine of the angle? Number 5, we are going to apply trigonometrical functions in finding the side lengths and the angles that are missing in a triangle. Then the last subtopic, we're also going to look at the angles of elevation and depression. So let's dive into the first subtopic here. The first subtopic is the introduction to this broad topic called trigonometry. Now, what is trigonometry? Trigonometry is part of mathematics, or it's a branch of mathematics which deals with the relationship between the angles and side lengths of a triangle. So here basically we look at angles in triangles together with the side lengths. Then what are trigonometrical functions? Trigonometrical functions are functions used to relate the angles and side lengths of a triangle. So it means we shall look at how the side length and the angles in a triangle are related to each other using a function called the trigonometrical function. Now, keeping in mind that a function has an input and an output. Now, there are a number of trigonometrical functions such as sine, cosine, tangent, so many other, cosecant. These other functions are for again another level of mathematics that is not part of this level of Form 3 work. So we shall only emphasize the 3 trigonometrical functions, that is the sine function, the cosine function and the tangent function. Now let's just look at briefly what are some of the formulas of these functions. Remember, we are going to derive them from the unit circle and from the triangles, but for the meantime let's see what they are. Now we have a mnemonic called the SOHCAHTOA. A mnemonic is called the SOHCAHTOA, used to remember the formulas for sine, cosine and tangent. Let's look at this right angle. Basically in trigonometry, the trigonometrical functions are actually become important, or they become meaningful when we look at them on a right angled triangle. Otherwise, if there are other types of triangles, then we always create a right angled triangle. So within that triangle, it contains the opposite. The opposite is the side that exactly faces the angle. Then we have the adjacent. Then we have the hypotenuse. The hypotenuse is the longest side. Then the adjacent supports the right angle and the angle theta. Or the angle theta. Theta is a Greek symbol to be used for angles. Other symbols are there such as beta, gamma, etc. Now, we can observe from this triangle, we can call the opposite as y, the hypotenuse as r, the adjacent as x. Now, sine, S stands for sine. Sine the angle, this angle is called the key angle or the reference angle or the angle we are interested in. We can also have an angle in this corner, but we are not interested in it, so it's not the key angle, neither is it the reference angle. So sine will be given as opposite divided by the hypotenuse. From this SOHCAHTOA expression, cos will be adjacent divided by hypotenuse. So cos the key angle will be adjacent divided by the hypotenuse. Then we shall also have tan the reference angle will be opposite divided by the adjacent. So from this mnemonic we can be able to build those formulas. Briefly on the Pythagoras theorem. Pythagoras theorem says that the longer side is squared. So Pythagoras theorem is going to be important in handling some of the questions in this topic here. So the longer side squared is the hypotenuse will be equal to the adjacent squared, x squared plus y squared. So by squaring the shorter sides, we can get the longer side there. I hope that's very, very clear. Now let's dive, this is a small just introduction about trigonometry. Now let's dive into the next part called the unit circle. The unit circle gives us a relationship between, in fact, it's just used to express the trigonometrical functions on the xy plane. So we've been expressing them in a triangle, but we are going to express them in a special circle called the unit circle. The unit circle is our next discussion. Unit circle. Now, the word unit means one, so a unit circle is a circle whose radius is equal to 1 unit. 1 unit does not mean 1 centimeter, because even 5 centimeters can refer to 1 unit, 10 centimeters can refer to 1 unit. So in brief, we are going to draw our circle of about 5 centimeters. That one you can draw it in the book, but for my case, I'll just sketch it here right away. So that circle, you can draw any length. The radius can be any length, but keeping in mind that when we're expressing it on the xy plane, then any length can be expressed as a unit, as 1 unit. So we are expressing it as 1 unit, a circle. So from this unit circle, we are going to build the formulas for cos, tangent, cosine, sine, and tangent. So that's our unit circle. Unit means it has a radius of 1. Anywhere that we prefer to draw, the radius is 1. Even from here to here, the radius is 1. That only means that this coordinate is actually being on the xy plane. So if this is the xy axis, then this coordinate is exactly 1, 0. Then this other coordinate is exactly 0, 1. Then this other coordinate down here being that 1 unit, this is exactly 0, negative 1. Then this is exactly negative 1, 0. So I hope we can observe that very, very well. So this length is 1 centimeter. keep also in mind that this is the x coordinate, the y coordinate, and every x coordinate is exactly representing, so the xy coordinates are actually standing for cos theta and sin theta. Now we are going to measure all angles taking this x-axis as the reference line, the zero axis. So when we're on this line, the angle is not measured at all, so the angle is 0. If you punch in cos of 0, you get 1, and if you punch in sine of 0, you get 0. So that only implies that the coordinates on every coordinate on the circumference is actually in terms of cos and sine. Let's fill in those coordinates. Let me use the angles with the exact ratio such as 30 degrees, 45 degrees, and 60 degrees. Let's dive into that. If this angle is 30 degrees, punching into cos of 30 and sine of 30, we can get this value here. But there is a simple way you can arrive at those coordinates in each section here. So looking at this point as 0, every other unit will express root 0 out of 2. So the next one will be root 1 out of 2. The next one root 2 out of 2. The next one root 3 out of 2. The last one here will be root 4 out of 2. So root 4 out of 2, so we can now have the next one, we can now build from 0 this way, root from 0, this 0 here, so this is root 0 out of 2, root 1 out of 2, root 2 out of 2, root 3 out of 2, then root 4 out of 2. So root 4 out of 2 is actually 1. So you can punch in here 1, and root 0 out of 2 is actually 0. So let me leave it there for recalling purposes. Root 4 out of 2. So this is actually 1, this is actually 0, because of course root 4, this is just a way of remembering. Just build from 0 on this x value moving downwards or clockwise, then build from 0 moving anti-clockwise using the y values from this axis, 0, 1, 2, 3, 4. Now we should note that angles measured in the anti-clockwise direction are actually positive in trigonometry, while angles measured in the anti-clockwise direction would be negative. Actually this angle would be positive 30 and this angle down would be negative 30 in case you measure like this downwards in the clockwise direction. Then if this is the 0 angle, from here to here is 90 degrees, then this is 180 degrees, then this is 270 degrees, then back here 360 degrees. So we can realize now that cos of 270 is actually 0, while sine of 270 is negative 1. We can also see that cos of 180 is negative 1 and sine of 180 is actually 0. Now we can relate this one to an equilateral triangle to be able to come up with the formula for sine, cosine, and also relate with a right-angled isosceles triangle to be able to reduce the formula of tan. Now by observation, other angles here, so we can always draw a triangle here, and each x value here be represented by cos, then the y value will be represented by sine. Now you should understand that angles this way are just reflected this way, and they can also be reflected down, but what would be changing is the location of the x-axis and the y-axis to create a negative or a positive. Now by observation, if we turn this side, this first line for 60 would fall exactly here. This balance is from here to 30, so if we added 30, we get 120. Then if we looked at 45 here, it would give us an angle of 135, And if we looked at 30, it would give us an angle of 150 here. If we just work backward, 180 minus 30, so that would give us 150. Now the exact ratios or the values corresponding to 120 are actually we look at the axes here. X-axis is negative, so it would make this value negative. So this would be negative a half with root 3 out of 2. The y value is positive. We're on the positive axis and the negative axis. So at 135, I would actually have this as negative and this one as root 2 out of 2. That one, then this one would be negative root 3 out of 2, giving me 1 out of 2 for this. So down there will be the same values, keeping in mind that both x and y are negative here. So all these coordinates will receive a negative down, and similarly down here x will be positive, but the y values in each of these are going to be negative. So we realize that in some of these quadrants, you see that this is the first quadrant, both x and y are positive, or both sine and cos are positive. If we dive into the next quadrant, the second quadrant, we realize that here the x is negative, that means cos is negative and the sine is positive. Because y is positive, because x represents the cos and y represents the sine. So diving into this the third quadrant, we see that both sine and cos are negative because both axes are negative. And looking at the fourth quadrant or the last quadrant, both the cos is positive but the sine is negative because y is negative. So that's about what we call the unit circle. Now this way I've put for you some numbers for exercise, so you'll try them out. Let's now get the formulas of cos and sine by relating this unit circle with an equilateral triangle. Now, let me create space here for myself. This is cos theta, sin theta. Now, we are aware that, so we are deriving formula for sin theta, cos theta. So here we say let's start with an equilateral triangle. Now for a matter of convenience, we shall let each length be 2. Just let the convenient values that can give you actually the results you want. We could use 1, 1, but wouldn't be convenient to derive our formulas very easily. So an equilateral triangle has all sides equal and all angles are 60. So by being 60 all angles here, if I divided this length into 2, it creates a 1 on this side and 1 on that side. So we are able now to look for this other side, the height here. So the key angle we are interested in is 60. This is 30 and 30. So let's dive into one right angle triangle out of this diagram. So I'm removing this one. I'll have here 2 and 1, taking 60 as the key angle or the reference angle for coming up with the formulas. If this is A, by Pythagoras theorem, we would see that the longer side squared is equal to the shorter ones like this. By solving, you'll get A is equal to root 3, so this side is root 3. So actually, our height is actually root 3. Now let us try to compare with our triangle, with our unit circle here. By looking at our unit circle, let's look at angle 60. 60 is actually corresponding to this line here. If we draw this kind of right angle triangle, we see that the angle 60 has a cos of a half. So cos of 60 is a half, while sine of 60 from our unit circle is root 3 out of 2. By comparing the results with this diagram, we see that cos of 60 has 1 as the adjacent and has 2 as the hypotenuse. So we can see that actually this one is the hypotenuse, which is 2, and this one is the adjacent. So we can see that this actually corresponds to the adjacent over hypotenuse. Then sine, of course, it is reflecting the opposite, which is 60, opposite divided by the hypotenuse. So I think you can see how we come up with the correct formula of sine and cos using the unit triangle and comparing it with an equilateral triangle. We can also compare it with actually what we call a right-angled isosceles triangle. So let's try to use a right-angled isosceles triangle and see if the same formula will remain. A right-angled isosceles triangle has two sides which are equal, and we are letting them be 1 unit and 1 unit for convenience in deriving the formulas. So keeping in mind that this longer height by Pythagoras, if this was a squared would equal to 1 squared plus 1 squared, and finally a would be root 2. So this would be root 2, of course, plus or minus, but we are ignoring the negative sense to be able to move on with consistency. So now if we looked at 45 here, the cos is actually, cos of 45 is actually root 2 out of 2 from this unit triangle, unit circle, but we can see that it's actually equivalent to a value called 1 out of root 2 by rationalization. So by observation, this term is the same this term here, and also sine 45 is actually root 2 out of 2 from this unit diagram. Then we can also, it is the same as this value, because if you rationalize this you get this, which if we looked at our diagram we can actually see that if 45 is our reference angle, then this is the opposite of hypotenuse for sine, and also adjacent of hypotenuse for cos. So cos 45 and sine 45 share the same answer. We can actually also make a conclusion that actually the formula remains the same there. Then let's use the same unit triangle to come up with the formula for the expression of tangent. So let's clear off this to create space to see how we can arrive at the expression for the tangent formula, since we have already derived the formulas for sine and cosine. Now going back to our unit triangle here to see how we can arrive at the formula for tangent. So our unit triangle, now we can still understand that if you created any line there, this would be 1 unit because the radius is 1, and this is our key angle or the reference angle. Then these are axes x and y respectively, keeping in mind that every coordinate is actually cos theta and sin theta, x and y. So the x value, so if we created this triangle, so this value would be standing for y, which is actually sin theta. Let me write it horizontally here. So this is sin theta. Then see sin theta, then down here would be standing for cos theta. Now let's draw a tangent, because we are looking at the tangent. What is the expression for the tangent? A tangent is a line that just touches the circle at a point. So drawing a tangent here. So if this is our tangent, we are now looking for this tangent. What does this tangent stand for? We can call this unknown letter A. So from this tangent here, we can observe that if this angle, maybe putting it here, every tangent property says that every tangent touches the radius at an angle of 90. So this angle is 90 degrees. Now if we extracted those two triangles, we can observe that if this was 30 degrees, then definitely this would be 60. Then this would be 30 if this was 90. So it means this other angle in this section is theta, and also this is theta. So we can remove out two similar triangles out of our drawing there, keeping in mind that this other angle is 90, is actually one got by subtracting 180 minus 90 and 90 here, which is actually 90 minus theta in other words. So this angle is 90 minus theta, and inside here would be actually theta. Let's remove out this triangle. All this, because this triangle is placed at 0, writing it in a standard way, ABCD. If we extract out triangle ABCD, this angle being theta, this length is 1, and this is cos theta. Let's extract out this other one. This has theta here, so it has sine on this part, then it has A on this section here. Now we observe that the opposite for this is this side, which has nothing, and it's opposite to this one. Then the hypotenuse is A, the hypotenuse is this. The adjacent is actually called theta, the adjacent is sine theta there. So we can use similarity. By using similarity, we observe that A out of 1 is the same as actually sine, because sine is the adjacent over cos, which is also the adjacent. So the tangent, which we are calling A, the tangent called A is actually sine divided by the cosine of the angle. So we have derived the expression for the tangent there, but we can go back to our expression in our diagram and check from our, so this is tangent. So you can go back to the unit circle and try to find out some values. When we divide the sine value of a cos value, we are getting a value called a tan value. So actually let's check from here. Sine theta is actually opposite over hypotenuse. Then we are going to divide it by cos, which is adjacent, over hypotenuse. Finally we arrive at tan theta being opposite over adjacent. So we observe two formulas here, tangent as this and also tangent as the ratio of sine to cos. So that's how we arrive at those formulas in our expressions. Now let's dive into actually the next subtopic under here. So our next subtopic in the discussion here is actually finding the sine, cos, and the inverses. Finding sine, cosine, and tangent, and their inverses and their inverse. That's our next subtopic here. So we can say find the sine, the tangent, and cosine of each here, each angle. So you can have 30 degrees, can have B 60, can have C 50 degrees, can have D negative 120 degrees. So let's find now on our calculator, we just look for the function called the sine. So if I'm finding sine of 30, go and press on the calculator, but ensure they calculate in degrees by checking the mode button. So if it's in degrees, look for sine of 30. Of course, we've already seen it from the unit diagram that some angles such as 30, 45, 60, 90, 180, 270, 360, and 0 can be memorized from our unit diagram. So this one is giving us, of course, a half. We can check it from the unit diagram. Then cos of 30 is actually 0 point on our calculator here. Cos 30 is actually 0.86602540, whose exact ratio is root 3 out of 2 from the triangle. So let's try now to find also sine of 60. I mean cos of 60 and sine of 30. Punching in cos of 60, cos of 60 is a half and this one is root 3 out of 2. So we can observe that sine and cos are complementary to each other, that sine of 30 is actually cos of 60 and cos of 30 is actually sine of, cos of 30 is actually cos 30 is sine 60. Hope I've punched that right in. Cos 30 is the same as, because this is sine 30 which is a half and cos 60 is a half. So sine 30 is the same value as cos 60 and also cos 30 shares the same value as sine. We punch in sine 60. So this is sine 60. So we can see that cos of theta, cos of any angle is the same as sine of 90 minus that angle. So like cos of 30 will give the same value as sine of 90 minus 60, which of course will give cos of 30 is the same as sine of 60. Hope we observe that. So that's how we punch in to get the angles. So you can punch in that just directly the calculator and it will give you a value. Then you write it down. At least write for decimal places or at least write all the values. So let us see how we can find the inverses or find back the angles given the trigonometrical values. Find the values of x and y given. So I can give you sine for sine x is equal to 0.6672, then tan y is equal to 0.972, have this 4.9721. So to find the inverse, we are taking we are putting into consideration that both x and y are only acute. It's when they are only in the positive quadrant. So we shall look at in trigonometry 2, if in case x and y are obtuse or reflex, then these values definitely will have to change. So if we are looking for the value of x, we take the inverse function, or we say we call it acasine of this value here. Then we punch it to the calculator. So we can either represent like this. So acasine of this value, then this value would actually give us shift sin of 0.6672, gives us 41.8. Don't forget that the calculator should be in degrees, so we can round this value 1.85 degrees. So if we are punching in here, we shall take tan inverse of this, which is actually 9721, giving us about shift tan of 4.9721, gives us actually 78.62825,311, giving us 78.63 degrees. So that's how we find their inverses, or we call them the inverse functions, or the arcsine, arccos, and arctangent. Let's dive into the next subtopic here, where we are applying sin cosine to find some unknown length in the triangles. So application of sin, cosine, and tangent. So application of those. So we are applying it and find the unknowns x, y, z in each, and have a triangle like this. If this angle is 60 and this is y, this is 4. So it's our triangle A. We can have this as x, and that is 4, 3. Let's try out this first. So we observe that this one has unknown length. This also z here. This has unknown length y, which we want. So we have to first identify which trigonometrical function is appropriate here. So we see that y is standing for our hypotenuse, 4 is standing for the opposite because it faces this angle direct. So we can try to first now. So our opposite is 4 and our hypotenuse is actually y. So our angle is 60. So we can apply sine theta is actually opposite of hypotenuse from SOHCAHTOA. So sine 60 is actually the opposite, which is 4 divided by y. So by computing, cross multiplying here, we see that y sine 60 is equal to 4. So dividing through by sine 60 to sine 60, we arrive at y as having a certain value there. So we punch into the calculator there right away, 4 divided by sin of 60. We are getting something like 4.618802154, which you can round to any decimal places of your choice. Now let's dive into this other one where we need the angles. Now let's start with one by one. If my key angle is z, then I keep x as unused, so z will be my key angle, the reference angle, the angle of interest. So any side facing z will be the opposite. So value of z, to find z, my 3 is the opposite, so opposite is 3 and 4 is standing for the adjacent. Adjacent is 4, so we are going to apply tan here. So tan z will be the opposite over adjacent. So we can try to punch in there. Tan z is equal to 0.75. So by solving for z will be the tan inverse of 0.75, giving us tan inverse of 0.75 is actually 36.86989765. You can round off to something maybe 0.87 degrees. You can find this other angle x by taking x to be the key angle, then 4 will be the opposite and 3 will be the adjacent, or rather we can subtract from x plus z plus 90 gives us 180, where we can now work out as x plus 36.87 plus this equal to 180. Then finally you can solve for your z there right away by subtracting 90 minus those two angles, and finally you'll get 53 point, you're getting something like 53.13. So you can either just punch into the angle sum of a triangle, or rather you can the other time solve by any trigonometrical function there, which is better. So that's the application, how we can apply the trigonometry in finding these unknown sides. Now let's dive into the last part here called the angle of elevation and depressions here. So what's actually angle of elevation and what is angle of depression? So angle of elevation and angle of depression. Now angle of elevation, is the angle that the line of sight makes with the horizontal measured upwards. Then on the other hand, angle of depression is the angle that the line of sight makes with the horizontal, but this time measured downwards. So those are the key definitions. We can have an illustration that actually to elevation is actually to look using the eyesight, but look towards a point above you. So that means in our sketch, if this was the eyesight, then actually somebody would be looking at such a point here. Then if we draw a horizontal at that point there, then the angle we measure from that horizontal is actually called the angle of elevation. So theta is the angle of elevation. Then this is the line of sight. Then this stands for the horizontal line. Then this is the angle of elevation. Angle of elevation. Then if you looked downwards to a certain point, then we're interested in that point. So the angle measured downwards from this line, the horizontal, so this is the line of sight still. Then this theta would be the angle of depression, where we can now draw other lines to connect the whole triangle up. Then we can use the knowledge of alternating angles and other angles to come up with the final observation. So now let's look at very well here two examples, one on depression and one on elevation here. So let's look at two examples right away. Boy of height 1.2 meters observes a bird, observes the top of the tree at an angle of elevation of 50 degrees if the distance between the boy and the tree is 40 meters. Find the height of the tree. Find the height of the tree. Let's sketch that. A boy of height. So a boy has a lower height than the tree. So I sketch him kind of shorter than the tree. So this is the ground level. And now this one. This is the elevation of this boy. So this is the eyesight. Then we must always have a horizontal. So this is the angle 50. So the boy is 40 meters, which is the same 40 meters here, but the height is actually 1.2 meters. So we can let this height be h, so that after solving for this, then actually this will be the added height to make the height of the tree. So this is standing for our tree, then this is the boy. So this is a boy, then this is the tree. Now let's punch into a trigonometrical function to aid us get this height here. So you can observe in this triangle here, we see that h is the height, h is the opposite to this angle, then 40 is the adjacent. So you can call in tan. So tan theta is actually opposite divided by adjacent. So tan 50 is actually the opposite h divided by the 40. So we cross multiply. H is equal to 40 tan 50. So we can get a value there by punching into our calculator. 40 times 50 gives us 47.6701437. Then height of the tree, we are now going to add those two, 437 plus 1.2. So add 1.2, we get 48.87. From then that you can now round off to a better decimal point. So you can have 48.87 meters. Now let's look at a question on angle of depression, angle of elevation rather, example 2. From the top of the house, the angle of depression of a squirrel, which is on the ground, is 6 degrees. If the height of the house, if the height of the house is 3.5 meters, find the distance of the squirrel from the base, from the foot of the house. So let's dive into that. Let's read it together. From the top of the house, the angle of depression, so we are looking from up. So if you look from up, then the angle we look at is this, not this inside one. So let's sketch that right away. So by observation, this is our squirrel. You can have it illustrated there. It's the squirrel. Then this is the house. Now if we observe this squirrel, our depression angle is actually this 60. So by alternating angles, this is also 60, but this is the angle of depression. So if the height of the house is 3.5 meters, it's 3.5. So now they want this distance of the squirrel from the foot of the house here. So I'm going to find the value of x there. So in this triangle here, can observe that I have the opposite at 3.5 and also I have the adjacent here. So opposite 3.5 meters, adjacent is the unknown x meters. Then so I'm going to call in tan the angle is actually the opposite, which is 3.5 divided by the adjacent. So by cross multiplying, x tan 60 is equal to 3.5. So divide by tan 60 by tan 60, we get right away x is equal to, let's punch into the calculator there, 3.5 divided by tan 60. 3.5 divided by tan divided by tan 60. So it's giving us 2.020725942, which of course roughly can be 2.02 meters. So that's the distance. So you will conclude and say the distance of the squirrel from the foot of the house is 2.02 meters. Now, thank you for watching. I request that don't give up. Follow this series. They will be in the playlist. And please subscribe this YouTube channel. Please, it's a kind request so that you keep me going to build this channel for better work. Bye. See you in the next topic 3.